Okay, we are on chapter 2's practice questions at the end of the chapter on page 68, looking at 5G, right?
Yeah.
So page 68, 5G, and it says 3x to the power 5 over 7x to the power 4 divided by, and we've got 6x to the negative 6 over 14x to the negative 4. All right. What I do with these, obviously, first thing, your KFC, your keep flip change rule, when we're dividing with fractions, because I have, although it's algebra, it's still a fraction divided by a fraction, right? So I'm going to say then that becomes 3x to the 5, 7x to the 4. Keep the first fraction, flip the second fraction, so I'll get 14x to the minus 4 over 6x to the minus 6, and change the divide to times. So that's the first thing I'm going to do. Whenever you're multiplying fractions, the rule is simplify before you multiply. So I'm going to see if there's anything in the numerators that can divide out with anything in the denominators. I have a 3 in this numerator, over 6 in that denominator. So I can divide that by 3, and that cancels out and leaves with 1. And I can divide the 6 by 3, and that cancels out and leaves me with a 2. I have a 7 in this denominator and a 14 in that numerator, so I can say 7 into 7 goes once, 7 into 14 goes twice. So basically what I have here is that's my coefficients are eliminated there because 1 over 1 is just 1. Here I've got a 2 over 2, so that again can cancel. And I can say 2 into 2 goes once, 2 into 2 goes once. All of the coefficients cancel out, so I have no coefficients. I'm then going to write my x down, and the powers, I'm now going to accumulate all my powers on the x based on whether I'm multiplying or dividing. The rule says if I divide by a power, I subtract my powers. If I multiply, I add them. And they're all x to the power of something. So I'm going to start with my x to the 5, which I have over there, minus 4, because it's x to the 5 divided by x to the 4. So it's a dividing problem there. Then I'm going to add the negative 4. I'm just going to put the add and the negative 4 there, just so that you're still with me that I'm adding that. Obviously, a plus and a minus together will make a minus, so that will become a minus over there. And then I'm going to subtract from that, because the x to the minus 6 is at the bottom, the minus 6. And again, you don't have to write minus 6, but I write it just to remind me that a minus and a minus make a plus. And then I'm just going to work through and see what's left. So 5 minus 4 is 1. 1 minus 4 is negative 3. And then negative 3 plus 6 is positive 6. So I'm left, positive 3. So I'm left with x to the power 3. So this horrible looking algebraic fraction simplifies down nicely to just x to the power 3.
Okay.
Make sense?
Yeah.
Awesome.
I struggled with J and K as well, but they're just pretty much the same.
Okay, J and K as well. So yes, well J, well let's look at them anyway. So J, you have 4x to the 12 y to the minus 3. So that's 4x to the 12 y to the minus 3, and that is over 12 x to the minus 7 y to the 9. Again, I start with my coefficients. So we always start with the numbers in front of the x's. I've got a 4 and a 12. 4 goes into both, so divide the top by 4 and I get 1. Divide the bottom by 4 and I get 3. So I've got 1 over 3. The 1 obviously will disappear because we don't write the coefficient of 1. Then I'm going to work out my x's and my y's. So I'm left with 1 over 3 And then I'm going to do the same thing with the x's and the y's that I did with that x. I'm going to write down the x's first. I have a 12 at the top, minus a negative 7, because the x to the 7 is being divided. And then I've got a y to the minus 3 minus 9. Happy with that?
Yeah.
12 minus 7 becomes 12 plus 7, and that's 19. So then in my numerator, because it's a positive power, so it's in the numerator of x to the 19 over 3, and I don't have to write the 1 now because the 1 is just in front of the x. Negative 3 minus 9 is going to be negative 12, and a negative power means it goes below the divide line, so I put it down there with the 3, and I make it y to the 12. And it's just a case of manipulating your exponent rules. So just using your exponent rules, if you're multiplying, you add, if you're dividing, you subtract.
And then it would just be k left.
And then k, so we've got, just quickly get that up for you. So we've got 14 p to the 5, q to the minus 4, over, actually let me give myself more space here. You've got all of this down here,
Yeah.
so can you raise that? And then Ange and Lucy, you can always just pause the video if you need to. Right, so k, you've got 14 p to the power 5, q to the minus 4, and again we've got another fraction here, so it's 30 p to the 4, q to the 4, and this time it's multiplied by, good, so there's no key flip change, I just have to leave it as it is, 5pq to the minus 7 over 2p to the minus 4 q to the 5. Now obviously, Carl, the way I do it, where I put all the exponents together on the p is one way, but you can also cross divide if you'd rather do that. It's up to you how you're going to do it. Again, simplify before we multiply, right?
Mm-hmm.
What can you see can be cancelled out?
So 5 can go into 5 once.
Good. 5 can go to 5 once. That's going to take the 5 out. So we've got a 1 there. And then
6.
And into 36 times. Good. Anything else?
2 can go into 2 once.
2 can go to 2 once. Good.
And then 2 can go into 14 7 times.
And into 14 7 times. And then 7 is a prime number, so there's nothing that can cancel between the 7 and the 6. So I know I'm going to still have a fraction of 7 over 6. And then using the method that I use, I'll take my p, and I'm going to write all the powers of p together depending on whether we're adding or subtracting. And the order doesn't matter. So I'll show you, I'll use a different order this time. I'm going to just go across first. So 5 plus 1. So p to the 5 plus 1. So I've got that 5 and that 1 added. And then I'm going to go to the bottom and sort out the denominators. Minus 4 minus negative 4. So I've subtracted that p to the 4 there. And I've subtracted that negative 4 power of p over there. And then the q, I've got a negative 4 plus a negative 7. And again, you don't have to write the plus minus. I'm just doing it now because what you do, follow the logic, and then minus 4, because I'm subtracting that power of 4 that's underneath the first fraction, or the denominator of the first fraction, and the second fraction has a denominator, has a power of 5, so we're going to minus 5 as well. So I've sorted out now all the powers of p and all the powers of q. That's going to be 7 over 6. Now, starting with the p. 5 plus 1 is 6, right?
Yeah.
6 minus 4 is 2. A minus and a minus makes plus. So I've got 2 plus 4 brings me back to 6, and it's a positive 6, so I'm going to write it behind the 7. Being a positive power means it'll be part of the numerator and not the denominator. I go to the Q, negative 4, a plus and a minus makes a minus, so it's negative 4 minus 7, which is minus 11. Minus 11 minus 4 is minus 15. Minus 15 minus 5 is negative 20, which means the Q belongs in the denominator, so I write it down as Q to the power 20. We always, in our answer, we always leave the thing with positive exponents. So if it is negative, put it down in the denominator. Can you see if you break it down to step by step,
Yeah.
it actually becomes quite easy.
Yeah.
And it's just a manipulation of your rules. And was that all you struggled with in that whole piece?
Pretty much. I think that's fine for the rest of it.
Well, that's wonderful
Yeah,
news.
a lot of it you could just actually do in your head.
Yes, yeah, these first 2 chapters, a lot of it are, especially where they've got the non-calculator ones, you can
Yeah.
just work those out in your head, that's quite easy.
So I'll just continue on with the rest.
Yes, that's it. Okay, and then for Ange and Lucy, if you have any questions, just drop me a WhatsApp and I'll send you any help on those. We've done so far with Kyle, we've done chapter 1's end of chapter exercises and chapter 2. So we're just going to revise right through again the book just as we prepare for the final exams. Good. Right, I can stop the video, I guess.
Mm-hmm.